You're listening to the Valley Current.
So I want to just open up by saying thank you for the paper. I'm going to maintain confidentiality, but we can at least talk generally about the title, right? Can't we? The greatest risk factor for the leading cause of death is ignored. That's quite a sexy title that you put on it.
Yes. Well, the ideas that I have in that paper have been expressed before in public to groups of interested people, but mostly scientists. But I've not written it up as extensively as I have, or as an invited paper. The editor of the biological sciences section of the Journal of Gerontology had read a very short version of that paper that you have, short, by short I mean a couple hundred words, that appeared in the Gerontology Society of America newsletter. And she was so impressed with it that she invited me to write this 5,000-word paper expanding on my complaint.
Well, I love the fact that you wrote 3 to 5 keywords, not in the title, that they want you to describe the entire paper, and you got it down to aging etiology disregarded by all. And it's like 5 words with a period at the end.
I think I have a few more words left to stay in keeping with their rules.
Okay, so you're going to work this over a few more times. I mean, how many hours do you put into something like this, not beyond the 70 years that you've spent getting to this point in time? How many hours do you put into writing a paper of this type? I'm kind of curious.
Well, so far I've spent, I would say, at least 15 or 20 hours at least.
More like 50 or 100 hours here.
Well, I don't think it approaches 100, but it's a substantial number of hours. A lot of it is spent, for example, I was several hundred words over the limit, and I've been spending the last 2 days telescoping some of the verbiage into a smaller number. And that's very time consuming in order to retain the content, that is, the substance of what existed prior to the contractions.
You know, the folks who write papers these days, they try to put a graphic or two into the paper to get the reader tuned into the whole subject. Is that something you're going to do in some version of this as well, or you don't think there's a graphic that is worthy of these points? Because there certainly are lots of graphics about the second law of thermodynamics, right?
There are no figures that are going to go along with this paper because there's nothing to quantitate, and consequently there is no figure to be made. I'm quoting the leadership of the major institutions in this country, that you can't make a figure out of statements, and based on their own statements I am making conclusions that are obvious to the reader. It would be nice to be able to make a figure that would contract a lot of the verbiage, but it's simply not possible. I've written more than 300 articles, book chapters, etc., and have in fact used figures in many of those articles. But this one, it's really not possible.
So when you think of what might be called the very big ideas that this paper is asserting as worthy of further study, one is that the whole area of the actual causation of death is understudied, right? The way in which cells deteriorate over time based on the laws of physics is understudied, right?
Yes, well, when you say it's understudied, it depends on the level of understudy, if I can put it that way, that you want to search. You can start with what molecular problems cause the death of something, or you could confine your request to what's listed on the ICD-10, which is the International Causes of Death, and there's many hundreds of causes listed there that are officially used by various entities. That does not address the causes at the level of molecules. So it's a very complicated problem. As a matter of fact, even causes of death written on death certificates are suspect, very suspect. Several years ago, I did a search of causes of death that were then attempted to be confirmed by autopsy. The first thing that you discover is that the number of autopsies that are done on the deaths of people in developed countries like this country has plummeted in the past 30 or 40 or 50 years, mainly because the cost has to be paid by either family members, which is rare, or by a hospital, which is only done when there is some question about the cause of death, or for legal reasons when the cause of death is suspect. But the bottom line is that the 3 studies that I looked at, and there were only 3 in which the number of autopsies that were done for various reasons at a specific location were sufficiently great enough to draw conclusions. And those 3, 1 in Israel and 2 in this country, indicated that on average, the 3 studies indicated that 40% of the causes of death listed on death certificates are wrong, as revealed by autopsy studies. And
so that's a pretty pathetic statement that the U.S. is that sort of lacking in greater specificity of that data, because in the area of COVID-19, it means there's going to be lots and lots of errors about comorbidities for sure, right? Among other things.
Yes, well, even more important are the decisions that are made in the entire biomedical field and in policy made toward health that are depending on these causes of death for which there is a 40% error rate. That's ridiculous. To come to what you have brought up in respect to the coronavirus, that is absolutely true. I don't know of any study that has been done in which a comparison is made between the cause of death attributable to a Corona-19 virus and the confirmation of that cause by autopsy study. First of all, it's a very dangerous thing to do if, in fact, the dead person has had the cause of death due to the virus, because the body obviously is loaded with virions. But even beyond that, the tests themselves, to say nothing of the alleged results, are highly suspect. I have not been able to find confirmation by independent entities for the safety, specificity, sensitivity, and reproducibility of the, I think they're saying about 10 tests for whether a person has or does not have, or is not infected with the coronavirus. Furthermore, those tests are just a single snapshot in time. There's no information in respect to those individuals, regardless of the outcome of the test. Their status 24 hours after the test is made, and even 10 or 8 or 5 hours after the test is made. But the dependence by policymakers and the gurus on television and radio and in print on their high dependence on the outcome of these tests is astounding. The testing is very unreliable.
But let me focus for a second on this whole question of what is understudied, because I have a graphic here, and you could tell me this graphic is irrelevant, but I'd like to hear your view. I just searched for a graphic that I think sort of puts up the point that you've been making in some of the earlier podcasts, that energy, entropy, and the second law of thermodynamics operates in a way that structure that exists, say, of a human body, of a human cell, of an organization, which is listed here on the right side as low randomness, low entropy, low disorder, over time, I mean, I would do this graphic exactly the opposite way. I would show time, I would flip it around, I would turn it on its head, as it were, and I would say, over time, this organized body of cells starts to disintegrate like a ice cube that's melting into a puddle of water. Over time, that's the natural entropic. Entropy acts over time on all of us the way that rusts a car and everything disintegrates over time, right? Eventually?
Yes, I do agree that that diagram should be reversed. But
right. If it were reversed, you would say that is the arrow of time operating on everything, whether it's a piece of leather, of a briefcase, or it's a human cell that represents skin, as skin starts to sag and disintegrate over time, as we know happens over time, because you can look at what happens as people age, their skin changes over time. And what was very smooth baby skin when they were just a little toddler becomes a lot of loose skin, including anyone could look at the picture of both of us as we've aged over time and try to compare it to other pictures. So I just put this picture up because I think in a way you're saying you want to understand how this breakdown happens in the human cellular activity, right? You want to know more about what's actually going on as the second law operates. Is that the point of the paper, or am I summarizing too much here?
No, you're pretty close to what I'm trying to express in that paper. But your example of the skin is only one of hundreds, if not thousands, of examples that could be given of the catabolic process of aging. That is the breakdown of materials at many different levels, depending on the interest that you have. My interest is the fundamental level of change that's occurring at the molecular level, leading to all of the changes at higher levels of organization. That is, from the molecule to organelles in the cell, to the cell itself, and onward up through organs and tissues like the skin. But the major concept is the increase in entropy. That is the basis of the second law of thermodynamics, which is really very simple to understand, and it was illustrated well in that figure that you showed.
Right. This one might be a little, it's still going in the wrong direction. For some reason, it's going in the direction as though the high randomness is becoming low randomness, but over time we know it actually goes in the opposite direction, where there's more randomness over time as things break down, right?
Yes, it's the dissipation of energy. And the energy in biomolecules, as molecules in living materials, is concentrated mostly in bonds that hold the atoms together in molecules.
This might be a better picture of, it looks sort of organized and the bricks are organized, but then over time, everything becomes sort of mixed together and disassembled.
Yes, because the constraints, you have to envision a biomolecule moving, or wiggling would be a better description. And the wiggling that does not occur in breakage stays in the wiggled form because the bonds holding the various pieces together are maintained. But over time, that wiggling motion breaks down because the energy of the bonds begins to dissipate. And that is the definition of the second law. The measurement, the quantitation, or the degree of energy dissipation is called entropy.
Right.
And the entropy has been increasing ever since the Big Bang. It was the lowest during the Big Bang and has been increasing ever since. It's found in very small forms in living material, as I just illustrated. But that constant increase in energy dissipation at the molecular level, after the constraints that were built by life's processes, all of the pathways, the biological pathways that contribute to the life of a living organism, that begins to break down. From an evolutionary standpoint, nature, or it's hard to talk about this teleologically, but from an evolutionary standpoint, the only necessity for the continuity of the species, of any species, is for members of the species, that is, enough members of the species to live long enough to reproduce. In the case of humans, that would be, let's say, about 30 years of age, which was, in fact, life expectation, let's say, in Roman times and before. So if you argue that human life began about 100, or the human species started about 100,000 years ago, and life expectation for 100,000 years ago until a few hundred years ago was about 30 years, then you can understand why it is only necessary for the survival of any species to have its members live long enough to reproduce. What happens after that is of no interest, at least in respect to the survival of the species. But humans have discovered ways to prevent causes of death, many causes of death, after the age of, let's say, 30 arbitrarily. So that now we are living for periods of time that teleologically nature never intended for us to see in the first place. The so-called successes, if you want to call them successes, are a function of the conquering of infectious diseases, and also especially the discovery of cooking. The cooking of food was a major step in the elimination of infectious diseases caused by viruses and bacteria and other microorganisms. So cooking plus the conquering of most infectious diseases, certainly not all of them, but infectious diseases that causes the death of youths, certainly in the past century or two, have all contributed to the increase in human life expectancy. But that increase from the age of 30 to what it was, let's say, at the beginning of the 20th century, 1900, when life expectancy in this country was about 48 or 49 years, it increased. So today, life expectation at birth is about, on average, 80 years for both sexes. But even the elimination, if you can do the math, and it's a very easy mathematical task, if you argue that all of biomedical research has succeeded in eliminating all of the causes of death written on death certificates, without the ability, of course, to eliminate deaths caused by homicide, suicide, wars, life expectancy cannot exceed about 92 years of age. So the increase in life expectancy by eliminating each cause of death found on death certificates comes up with some very interesting observations. The elimination of Alzheimer's disease, which I address extensively in the article that you have, the elimination of Alzheimer's disease as a cause of death will add about 19 days onto life expectancy.
So that would argue that all the money spent on Alzheimer's is really like throwing money to the wind, right?
Well, I agree with that in general. It is not unlike the war on cancer, in which money was thrown at that cause of death, and it did not result in really significant results. What happens in situations like that, and like the money that's being thrown at Alzheimer's at the Alzheimer's disease industry today, and it is an industry, is that the money seeps down to researchers or people who are working on the ailment at lower and lower levels of competence. The major players doing research in the field have really all of the money they want or need. The money is now seeping down, as I said, to lower and lower levels of competence or in areas of lesser and lesser direct interest and causality. So the focus on Alzheimer's disease occurred when Robert Butler, the first director of the National Institute on Aging and a good friend of mine, who was a psychiatrist and interested in Alzheimer's disease, among his other interests in mental illnesses, decided on his own to focus attention on research on Alzheimer's disease. And he did that almost to a fault. And I say that because in later years, when he realized the amount of money being spent on Alzheimer's disease and the enormous amount of attention paid to it, is that he stated publicly his regret in the degree of emphasis that he placed on it and what it was taking away, in arguments made by many other people, from the support that should be going to other diseases. It is also a false argument made by people concerned with Alzheimer's disease that the major problem is not only the victims of the disease, but the caregivers who suffer significantly from the care necessary to treat these poor individuals. But that argument is also the same for caregivers to victims of the three leading causes of death, of which Alzheimer's is not one, and that is cancer, cardiovascular, stroke, and cancer, cardiovascular disease, stroke, and cancer. They all require the same kind of critical attention by family members or paid caregivers, and the magnitude of support is probably greater for the leading causes of death absent Alzheimer's disease.
Well, if let's say that people took your paper extremely seriously, what reallocation of funding would have to happen in universities and colleges to actually get at the point that you're making in the paper about the area that's so understudied is sort of the law of physics more than laws of biology? What would they have to do to sort of set up the appropriate studies? It's almost like revamping academia towards something that probably would be viewed as heresy within most biology labs, right?
No, I don't think that's the case at all. In fact, at the end of the paper, I offer what I think are the suggestions to find out more about the greatest risk factor for the leading causes of death in this country and other developed countries. And that is the process of aging. The effort should not be made, because it, in my judgment, is impossible to reverse laws of physics. Effort should not be made to slow, reverse, or stop the aging process. What we need to discover is the molecular character of old cells that distinguish them from the molecular configurations found in young cells. The configurations found in old cells obviously lead to greater vulnerability to the major causes of death. The important fact is that in the past decade or so, there have evolved many unbelievably critical methods for measuring the status of molecules, not only at the molecular level, but at the atomic level. Something called electron microscopy, for example, can determine the configuration of biomolecules down to the atomole level, which is almost beyond description. But all of this is described in my paper. So what we want to know is the following. What is the configuration of molecules in an old cell that leads to its capability of increasing vulnerability to disease? The discoveries that could come from that is that all of the causes of death that are age-associated have a common cause in the milieu or the landscape of dysfunctional molecules or partially functional molecules found in old cells that are not found in young cells. We have the capability to do that. And that is not something that cannot be undertaken. I have argued by the National Science Foundation, whose goal is not to focus attention on biomedical research, but on physical aspects of life and physical aspects of non-living entities. So that I argue that I can defend the lack of interest by the entire NIH to explore the greatest risk factor for the diseases that they're interested in by saying that they're correct, that actually that study should be done by the National Science Foundation, because aging is a problem in physics and not biology.
But when you look at the question of what would be the research design for what you're suggesting should be further studied, are they looking at like cells from infants and comparing it to cells that exist in someone that's in their 90s or someone that, say, is at 110, of which there are a few people that are at that level, and trying to compare the structure of the cells? Or is it more like, no, it's not static. It's like a motion picture. You have to look at what's happening over a lengthy period of time. You have to take cell samples from the same cohorts of people over what might be 100 years of their life or 110 years of their life. That kind of study takes a long, long time to do and requires a lot of volunteers, right?
Well, not necessarily, because it may come as some surprise, but there are banks of tissues and cells, in fact, supported by funds from the National Institute on Aging, that consist of biopsies of tissues, tiny biopsies of tissue, and cell strains also from humans over a period of decades of the lives of single individuals, so that you don't have to wait 10 or 20 or 30 years to do this experiment. The tissue and the cells are already available. And furthermore, you don't have to do it periodically over many decades, because the molecular constituents of young cells, that is from young donors, can be made at any time when a person's in their 20s or 30s, and then compare that with tissue obtained from the same individual, which I said are available when that individual is in their 60s, 70s, or 80s. So that's not difficult to do. The other point is that you can also do this in vitro, that is in tissue culture, where there again exists and banks of cells maintained by the National Institute on Aging, strains of cells derived from young individuals and old individuals. Those cell strains, of course, have a finite capacity to replicate, at which time they reach a condition called senescence, a phenomenon that I discovered some 60 years ago. So that one could study cells in that lineage that are both young and old, derived from the same donor and representing cells in a state of youth and a state of old age. so that all of these studies are doable, not only because the tissue required is available, but because the technology needed to look at molecules at the atomic level exist.
So what do you think is preventing it then, Len? Is there just not a motivation? Like if there was a drug that could come out of it, I imagine there would be a big motivation, right? But well, it's not likely you're going to produce a drug, right?
I don't think that there will be a drug that comes out of it. But the motivation is, and I can only guess at this, people in general in huge institutions like the ones I've been talking about are happy in the circumstances that they're currently in. The motivation to do something revolutionary is very low. It threatens their positions. And I will risk annoying any physicians who are looking at this video cast by saying that many of the decisions are made by physicians who have the disease kind of interest foremost in their minds. And aging is not a disease. I've pointed this out in the document that you have, and I've given, I think, 6 or 8 reasons why it's not a disease. So the disease paradigm does not work for studies on aging. The other part of the problem with the motivation is that people in private areas and politicians and legislators understand clearly what the leading causes of death are, because they themselves may be experiencing it in its early stages, and certainly know of people or heard of people who suffer from cardiovascular disease, cancer, or stroke. And so it's simple for them to understand why funding for research in those areas is required. And incidentally, I don't argue that funding for those ailments should be stopped or even reduced significantly. What I'm arguing is that the fundamental risk factor for all of these major diseases is aging, and that is stated just as I stated it, by the leadership of the major institutes at the NIH and by the director of the NIH himself. That's all quoted in this paper. So they do realize what the etiology, what the risk factor is, but there's total silence when it comes to implementing studies on this risk factor, this greatest risk factor. And that, as I indicated in the first sentence of the paper, to my mind, borders on scandal.
Right. And what I'm trying to get to is, if the scandal is recognized and folks say, really, this needs a structural change, we need to do a structural change from the disease model to what might be called the laws of physics model, what do you imagine would just start to fall into place as people structurally change the way they look at, sort of the laws of Copernicus changing to the laws of Einstein, or the laws of gravity changing to some different view of what these basic laws are doing to the human body, for example? What do you think would fall into place in the research agenda? Is there a new field that gets created where people who study physics move towards biology and medicine, or vice versa? In other words, you're more of a Renaissance man in a way. You've been able to extend yourself in the laws of biology as well as the laws of physics, or in the principles of biology and the laws of physics. There aren't a lot of people like you. There certainly aren't a lot of people like you left in the world. What would you say would happen? Because you could argue generically it's siloed. There's too much siloing of science. Science gets siloed in categories, in buckets. And then people in one silo don't know what people in another silo and what people in a third silo are doing. And it takes someone to look above the silos to say, you all have it wrong. There's some more general principle that's operating here.
The answer to that huge question is simply this, and it's pointed out in the paper. the leaders, the directors of all of the major health organizations in this country have been quoted in my paper, each one of them saying that aging is the greatest risk factor for X, Y, and Z. So they already know the truth. There's no need to convince them of a new concept. That concept has been written time and time again by the leadership of the major health institutions in this country. Consequently, what needs to happen is to implement research on what they all believe to be true, namely this risk factor. And I pointed out in the paper that the technology exists to do that, and all that they have to do is stop sitting on their hands and implement what they all have verbally stated to be the truth. Nothing could be simpler than that. How it's organized is another question. The organization or the plan to do that could be constructed within a week or so of consultation with experts in the various areas of research on aging, physicists, and I should say, incidentally, that the cause of the aging in biotic or living systems is the same as it is for abiotic systems. That is, for the aging of bridges, buildings, airplanes, you name the physical entity. So that the organization should include engineers, physicists, and biologists, because aging is a universal phenomenon.
Right. Next week, I'm going to read your paper further and have some further questions for you, but bravo to you for you're still writing and still spending the 20 plus hours to put together great papers that hopefully will educate all the rest of us on things that we need to fix and things we need to address. I hope there will be open ears for the presentation you're giving in Hawaii with this or somewhere else. Where's this one? Is this Hawaii?
Well, I will be giving a dedicatory lecture for a new building at the University of Hawaii in Manoa. But because of the present circumstances with the coronavirus, I won't be traveling to Honolulu to do that. I will be doing it by Zoom.
Well, that's too bad. You're not going to get to experience Hawaii in September, but it's a beautiful place. You know, I'm a member of the bar in Hawaii, and I always imagine having a nice office in either Honolulu or Maui with a beautiful beachfront office condo and having the ability to spend a few months out of the year in Hawaii. That's still in my head. And at some point, I hope I make that happen and get you used to that Hawaiian condo when you decide that you can go over, maybe next year whenever things subside here.
Okay, Jack, I appreciate that sentiment.
You're welcome.
Well, thank you for your interview and your interest in this subject.
You have a great 4th of July. You take care. I'll look forward to seeing you later this year. Bye-bye.
Thank you, Jack.
Bye-bye.
Tune in next time on The Valley Current.